Great, welcome to Idea Statica tutorial. Myself Jayarajan P. This is tutorial number 6. Here I will demonstrate how to model and design a circular hollow section CHS tension splice. So let us start Idea Statica tutorial number 6. So let us start from a blank project. So let us just fill it. So this is a tower structure, and this is we'll call it as a CHS splice 1, and we'll keep here as 355 grade steel. So we'll choose it as 355 grade steel. Okay. Then for the bolts, we can choose M24. So that is for a little bit larger angle bolt diameter. Okay. So the design code will keep as EC3. So create project. So let us start first adding CHS sections. So we'll press number. So select the CHS, and in the CHS we'll choose CHS 273. So we have it as a 273 by 6.3. Okay. So we have CHS 273 by 6.3. So okay. So we have generated one CHS member. So we have this will be treated as an entered member, and then all the parameters will be kept the same. So let us start modeling the other piece. So we'll keep the same section, and the angle we'll keep it as beta as 180. So this will be 180. Okay. So, and all other parameters will keep the same. So we can have a view. So these are M2 and these are M1. So what we can do is M1 will keep it as a okay. So M2 will keep it as a bearing number, so that we can apply the loads directly on M1. So we have developed two CHS numbers, M1 and M2. So let us straight away go for the splice plate operation. So we'll add operation. So here we'll go for a plate-to-plate member splice operation. So we have we'll choose 8.8 M24 bolt diameter. Okay. Okay, fine. So as you can see that a proper plate-to-plate arrangement splice is generated. So we need to now change all these dimensions. So we have member M1 as M1, M2, all these are the same, and the material for this plate we will keep it as S275. Okay, so we have to add it. So let us start adding S275. Okay. And the thickness of the plate will keep it as 20 mm. So we'll just add it. So increase it to 20 mm. Okay, and the connection type will be the bolted, and the dimensions is a circle. Okay, and we'll keep the radius as 240 mm. 240 mm, and the inner radius will give it as 0. So that defines the size of this splice plate. And then let us go for the definition of the bolts. So the diameter is already provided. So let us keep it at a radius of 190 mm. So 190 mm. Okay, and we'll use 8 number of bolts. Okay, and regarding the flanges, so here we'll use the web component to define the welds. So let us keep it as say 6 mm, 6 mm, and we'll choose only one sided weld here, okay, as indicated here. So and the material of the weld will be S275, so that's okay. So we have defined properly the splice plate as well. So the model is shown here, so we can have a look here. So this is a model. As you can see that the diameter is marked directly here, and it connects the two Chs sections, and the bolts are arranged in a circular pattern. So now let us start defining the load effects. So in the load effects, we'll be applying only the tension load for which the splice has to be designed. So we'll add the load. So in the load effects, we'll define it as a tension load, that is the N is equal to, we'll keep it as a 750 kilonewton, 750 kilonewton. That's okay. So we can say that is marked as tension. So now let us proceed for directly the calculations. So press the calculate button. So as you can see, this is the result summary. The analysis is performed for 100% of the loads, and the maximum strain the plate is 0.1%, less than the limit of 5%. And regarding the boards, the utility ratios are order of 0.8, and for welds also is approximately 0.8. So the arrangement is acceptable. So let us go for checking the strain as well as the stress distributions. So regarding the plastic strains, so we'll just mesh it up. So as you can see that there is a concentration of there's a concentration of stress strains in and around in the splice plate in and around the boards. Okay, so and here you can see that this is how it is something around say 0.1 percentage, that is the splice plate area surrounding the boards. And now going to the equivalent stress, so you can see that the equivalent stress is, the distribution is already shown here. And as you can see, there is a large stress distribution in the plate as well as some portion very near to the splice plate. Okay, so and we can also get an identification of the bolt forces. So you can say that the bolt forces are almost equal, right? So almost equal. So if you want to obtain the, you can also press here, and where you will find that the the tension load in the bolts directly. So that is VDFT. As you can see, that is almost uniformly distributed 164.4. Okay, and and we have the utility ratios are already listed over here. And let's see the utility ratios. So we find that intention is of the order of say 80.7. Okay, that is written here 80.9. So now we can also obtain an idea of the contact stress distribution as well. So this is how the contact stress are being distributed. So as you can see that the distribution, the contact stress happens around the outer edges of this splice plate. Okay, and you can see that these are well within the acceptable limits. So if you want to obtain the report for the splice, you can just press the report button. So these are all about the reports. So you can see that this is a picture of the tension splice connection, and these are the descriptions regarding the boards as well as the cross sections, and the check for the various components are listed here, including the boards, plates, everything. So in addition, you can also get the safety of the components as indicated here, the overall check part, and this is the distribution of the plastic strains, and this is the distribution of the equivalent stress. So you can also obtain the loads in various boards as shown here. So the code setting parameters are also given here. So that's all. So please subscribe to the channel so that you will start getting notifications as and when tutorials are uploaded in my channel. Thanks a lot.